Okay, so it's recording now. So anyone here, so today is our first day for IT fundamentals. Anyone here can tell me what is IT? Like, what does IT actually mean?
Information technology.
Okay, but what does it mean? What is information technology? What is information?
Information you are should know the when you're creating a network or creating a network, you should know the IT fundamental. You should know the uh, designs. You should know the types of cables, and this all of this are information, and you have to know the information about technology, and then you create that.
Okay. Anyone else who can explain information technology?
It's like, for example, sorry.
Go ahead. Can you repeat? Can you repeat?
Information technology can be a word, so maybe in different parts like hardware, software, programming, database. So yeah.
Okay. Cool. Sounds good. So every time when we talk about information technology, when we say information, information is where we are talking about data, right? Um, and technology is anything, the devices, the technologies that we use today. For example, laptops, mobile phones, they are like all technologies, and then what they do is they store information, right? That's what they do. So, how important is information technology today in your life? Can you live without it?
Well, it's so hard to say yes or no, but my point of view, no.
Okay, anyone else?
And no, we can.
You cannot. Okay. All right. Let me share my screen. It's basically where you use computer or other devices you can live without. It all depends, right? It all depends whether you can live without it or you cannot live without it. It all depends on that. Um, so screen 2 is there, document 14. All right. Can you all see my screen?
Yes.
Yes.
Yes, we can see.
Yes.
Yes.
Okay. So what I'm doing is I'm building a Word document where at the end of this class you will get like a book for IT fundamental, okay? So this is going to be like a book for IT fundamental. So in here, what are we doing is basically we are going to learn introduction to IT, where we will understand the true meaning and importance of information technology. We will learn what computer is, and we will also learn the binary language, okay? And then we will learn about computer components, and we will learn difference between hardware and software. We will learn about networking, database, storage, virtualization, cloud computing, and security. And then in our third section, we will learn about hardware. We will learn about RAM, CPU, motherboard. We will learn about external components, um, such as keyboards, monitors, mice, printers. And then we will compare computer components to human body. After that, we will learn about operating system, where you will learn different type of operating system. We will learn operating system boot process, and we will do like comparison of like command line, graphic user interface. And we will also learn about file system management. Then we will go and learn about software. We will learn about system software and application software. We will learn about freeware, shareware. Those are different kind of softwares. We will learn about BIOS. We will learn about program and services. The section 6 is going to be about networking. We will learn some concept about networking, and then we will learn about database, storage, virtualization and cloud, security, Windows operating system management, and a Linux operating system, troubleshooting concept, introduction to AI, and ChatGPT. We will also learn a little bit about artificial intelligence, okay? And ChatGPT. We will also see what DevOps is. So these are new concepts for you. If these are like new concepts for you, do not confuse yourself with it, because you're not gonna learn it in a way that you will work with DevOps. It's for programmers, developers, but it is very important for you to have the concept. That is why we need to know basics, because when you go and work somewhere, you will have a DevOps department in there, and then you should know what is their job, what DevOps does, okay? And then we will go through additional reading. All right, so let's get started. Introduction to information technology. Introduction to information technology. Let me check something here. Okay. So information technology refers to use of technology systems, right? Information technology is where we use, it refers where we use technology system, okay? Such as computers and telecommunication to store, retrieve, transmit, and manipulate data, right? So information tech, whenever we talk about information technology, we are talking about the use of systems. For example, you have a laptop, right? It is part of information technology. You have a phone. It is part of information technology. You have a smartwatch. Do you have a smartwatch? Anyone here have a smartwatch with them? Apple Watch or any other watch? If you have that, that is part of information technology. You got Chromebook from school. That is part of information technology. When you go to hospital to see your doctor, do you see they have like computers where they enter information about you, like your name, date of birth, and um, just for diagnostics, right? So that is a device that stores information, manipulate information, you can retrieve information, and that is part of what? Information technology, right? So information technology is a backbone of modern businesses, enabling automation, communication, and decision making. Do you think a business can run without technology in today's world? Do you think a bank or hospital they can run their business without technology?
No.
No, right? Anyone here who will say yes?
Kind of, but information technology make things easier for them and also for the patient. They can put all the information online. It can be more helping for the patient and doctor communication. Like they can
It's
communicate.
like in today's modern world, it is modern world now. And without information technology, things are not gonna run well. Because if it's hospital, the patient information, the payment information, diagnostics from one hospital to another hospital, all those things will take days and days, right? So basically, if you're able to do something that you're doing in 2 minutes, if you don't have technology, it will take maybe like 2 days, 3 days, 4 days, who knows, right? So, when we did not have technology and you had to send a message, you were writing on a paper and then sending it, and it was taking like 1 month or more to be received, right? Because there was no technology. Um, Now you have technology, it only takes second or less sometimes. You just click send, it's done. To send a message, right? You send an email, you send a message, you use Facebook, you use Instagram, you use all other technologies that you have, and you send it within seconds, correct? So that's why technology is really, really important in today's world. And if someone asks you what is information technology, information technology is basically, it refers to technology systems such as laptop, telecommunication devices that can store information, retrieve information, manipulate information, or information or data, you can say. And it is very, very critical part of life now and critical part of businesses today. Um, Otherwise, you are basically going to you're going to be in a challenging situation because you will have a lot of problems, right? Technology enables automation, right? It automates thing for you, correct? Um, And then we have definition of what is a computer, right? We already studied about this. So who can tell me what is computer? What computer is?
A computer is a machine that play a fundamental role in our modern society. It process a vast amount of data and execute instruction, and this all do the computer.
Okay. Anyone else who can tell me?
Yes, an electronics device, we can store the data and share the data and retrieve information when we need it.
Yeah. Anyone else? If you don't want to say it, you can also write it on chat, but participate. Okay. Yeah, computer is electronic device where you enter information and the computer takes that instruction, it manipulates it or processes it, and then it gives you the result. So what is CPU?
CPU is central processing unit. It's the brain of computer.
Yeah.
It's execute instruction and perform calculation in a computer system.
Okay. Who can tell me what is the language of a computer? What like we speak English, right? Right now we are speaking English and it is a language, right? Um, we all have different languages that we speak. Um, what is the language of computer? Is it English?
Computer use binary language like 0 1 1 0 1 like that.
Okay. Anyone here thinks the computer language is English? Yes, no. Say yes or no. Or say I don't know.
Yes.
Okay, you think it's English?
Well, most of the countries, yeah, it's English, I can
Okay.
say. But depend on any single users if they prefer, so they can change the language by somehow by reinstalling the operating systems and choose their whatever is available as per their media kit or let's say or CD, DVD, sorry.
Okay. Thanks. Thank you so much, Samir, for trying, and Anwar for saying I don't know, Hashmat for saying I don't know, and Zubair for answering. Thank you so much. So, computer does not speak Arabic, does not speak English, does not speak any other human language. Computer does not know human language. Computer only works on zeros and ones. Computer only works on zeros and one. The language of computer is zeros and ones. That's it. Binary. Like Shahid was explaining, right? It's zeros and ones. So in computer, binary is the fundamental language of computers. That's the short explanation, right? It consists of only 2 digits, right? It's 0 and 1. That's it. 0 and 1. Okay? 0 mean off, 1 mean on, right? 0
Yes.
mean off, 1 mean on. So 0 means off, 1 means on. Okay. So whenever you enter A on your keyboard, right? See? Do you see my screen? When I say A, see? Whenever I am entering this, the computer is not taking A as an input from me. It's taking it as zeros and ones. Okay? Because computer doesn't know what is A, what is B, what is C, what is D, or what is 1, what is 2, what is 3. Computer only knows zeros and ones. Okay? I am going to play a video for you now where you will see how A, zeros and ones actually work. Give me a second. Can you see my screen with YouTube?
Yes.
Okay, let me know when I play it, you can hear the voice. Can you hear it?
No.
Nope.
No?
Nope, you cannot.
Okay.
While almost
but
everybody
now.
knows that this is somehow related to what computers do,
Yes
very
or
few
no?
of us seem to understand what binary is.
Okay. So now, listen to this video.
Okay.
Why computers use zeros and ones?
It's a common theme throughout the modern world that everything in a computer's brain comes down to ones and zeros. You've most likely heard that this code of ones and zeros is what's referred to as binary. And while almost everybody knows that this is somehow related to what computers do, very few of us seem to understand what binary is or why computers use it. If you want to know, then this video is for you, because it's actually a very simple concept and still quite fascinating. Before we get to computers, let's talk about what binary itself is, as it existed long before computers did. Binary is nothing more than a system of counting. To understand how it works, let's look at two other systems of counting, tally marks and the glorious base 10 positional that we all know and love today. Tally marks are the simplest counting system imaginable. However many things you have, you put down that many marks, easy as pie, but not very efficient. Meanwhile, base 10 positional, which is what we use today, uses a different symbol to represent different amounts of things. With the numbers 0 through 9, we can recognize that each symbol indicates a different amount of things. If we need to represent something higher than 9, we add a digit to the left, roll this first digit back to 0, and start over. This system is very efficient compared to tally marks because each digit we add exponentially increases the amount of things we can represent. Because in this system we add a new digit every 10 things, each digit represents an increasing power of 10. This is the number of ones we have, the number of tens, the number of hundreds, the number of thousands, and so on. Now this is probably something you already know, but it's very important to keep it in mind when we talk about binary. Now binary works the exact same way as base 10 positional, but instead of each digit going from 0 to 9, it goes from 0 to 1. Counting upwards in binary sounds like this: 0, 1, 10, 11, 100, 101, 110, 111, and 1000. Because each digit of binary has only 2 values and not 10, each additional digit represents an increasing power of 2 rather than an increasing power of 10. So this is the number of ones we have, the number of 2s, 4s, 8s, 16s, 32s, 64s, 128s, and so on. Not nearly as efficient as base 10, but exponentially more efficient than tally marks. Literally. So now that we know how binary works, let's talk about computers. Why did the first computer creators, as wise and intelligent as they are, waste their time with such an ineffective system of counting? Well, it's because of a physical limitation on how computers work. Everything a computer does comes down to what's known as microtransistors. Simple, tiny, eensy-beensy little switches that can either be on or off, and can be flipped on or off with a very weak electrical charge. The first goal was to get computers to count, and to get them to count by using these switches, we could use the tally system, meaning the number of on switches equals the number of things we have, or we could use the much more efficient system of binary, where each switch represents a digit of binary. 8 transistors using the tally system could represent a number as large as 8 by turning all of them on. With binary, we can represent a number as high as 255. An on switch means a 1, and an off switch means a 0. Now is a good time to mention that a single transistor is what's known as a bit, which stands for binary digit. A byte is 8 of these bits in a row, which means any number between 0 and 255. So if binary is just a system of counting, what do people mean when they explain how to spell things in binary? Well, what they really mean is how to spell things with ASCII. The American Standard Code for Information Interchange is a way to convert a computer's data, which can only be in numbers, and turn it into letters for humans to have an easier time to work with. ASCII simply assigns a character to each value represented by a byte of binary. Now because a byte has 8 digits of binary to work with, and 8 digits of binary can represent up to 255 values, ASCII had 255 letters and symbols to choose from, more than enough for the entire alphabet, punctuation marks, and other symbols. For example, the corresponding ASCII number for an uppercase A is 65. Now 65 in base 10 is equal to 1,000,001 in binary. So whenever you type in an uppercase A in a word program, a coding program, or a scripting program or whatever, somewhere there's a little tiny row of 8 transistors arranged in the pattern of off, on, off, 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 on, which represents 0, 1, 0, 0, 0, 0, 0, 1 in binary, which is interpreted as 65 in base 10, which is converted by ASCII into an uppercase A. You're likely starting to get a feel for the staggering amount of transistors required to write something as simple as a Facebook status, let alone all the different coding that your computer has to do to make the screen light up, play games, calculate massive values, and so on. Well, long before we got to the point where your phone can play 3-dimensional games, it became clear that numbers as high as 255 just weren't going to cut it. Regardless of how many bytes we had, and it was a lot, even adding 4 fully active bytes together could only get a number as high as 1020. To solve this problem, new computers were designed to recognize 2 bytes as one single number. So now instead of referencing one line of 8 transistors, computers could reference 2 lines, giving 16 digits worth of binary. This was a huge help because it increased the amount of representable numbers exponentially from 255 up to 65,535. When you hear people talking about the difference between 8-bit and 16-bit, this is more or less it. Now that doesn't mean that a 16-bit system is exponentially that much more powerful, because your program isn't always going to be utilizing all of these numbers in each byte that it represents. It just has the option to, which opens up lots of doors. Well, this could go on for ages and ages, but I want to end this particular video right here so as not to be overwhelming. In future videos, I will explain how computers use these numbers to decide which pixel is what color on your monitor, what the different components of your computer are for, and how hard drives store binary digits on a spinning disk rather than in transistors. Thank you for watching, and if you enjoyed this video, liking and subscribing is always a huge help. While I've been enjoying making these instructional videos, I might move them to a different channel.
Okay. What do you think?
Um, it's it's a simple way of knowing whether something's on or off.
So, did you understand a little bit more about binary after watching that video?
Yeah, I understand a little bit. Like computer has its own language, it's binary language, and if we need to understand it, then we have to learn how to convert binary language into the decimal language.
Okay. Sounds good. Um, so can you see my screen, Microsoft Word? Yes?
Yes.
Yep.
Okay. So here I have an example. When you type hi on your keyboard, right? When you type hi on your keyboard, when you press H and I, the keyboard sends signal to computer in form of electric pulses, right? So you have a
Yes.
laptop, you type hi. What happens is your keyboard sends signals to computer in form of electric pulses. Each key on the keyboard is mapped to unique number based on ASCII table. So in your keyboard, there's a chip, okay? In your computer keyboard, there is a chip, and that chip has all the table, like A is equal to 01100, B is equal to 1100110. So there is a register on your keyboard, and all the letters like H, A, B, C, 1, 2, 3, @ question mark. It is all stored in your computer keyboard. There is a chip, and it is called register. Okay, it is called register. So for example, let me give you an example here. So for example, this is the keyboard, right? Inside the keyboard, there is a chip. Inside the computer keyboard, there's a chip, and then all the words A, B, C, D, 1, 2, 3, it has ASCII codes, and it is stored in there. So there's like a register, like a dictionary in there. And the keyboard already knows what A equals to. So you can see that in your keyboard, H is equal to 010010000. and then I means 01001000. So the keyboard already knows because it is on the table. It has a register. And then once you press it, the computer processes these binary codes through CPU, and the CPU uses this data to determine which pixel on your screen should light up to display the letters. Okay, so you and then the CPU basically shows those letters to you. HI. Okay, so that's how the binary letters actually work. All right.
Oh, H is a decimal language, or decimal.
Which one?
H and I, we call them decimal.
Though they're not decimal numbers. You mean H and I?
Yes.
So those are like decimal numbers, but when we talk about decimals, I think we are talking more about the numbers, right?
Hmm.
It's alphanumeric number, alphabetic numbers, alphabetic letters. Sorry, we're talking about. But again, whenever it comes to the main idea here is to know that the computer language is zeros and ones, okay? And that's how it actually works. Okay,
Yes.
so the next topic is computer components, and then differentiating between hardware and software. We did a study about this in our class, hardware and software. So who can explain it?
Hardware is like any physical stuff, you can touch it, like like a monitor or CPU, printer, scanner. And software is like a soul of the body, like software communication, used to communication in between user and hardware.
Okay. Anyone else?
Hardware refers to the component or physical component that we can touch and feel, like CPU, RAM, keyboard, and other. Software, on the other hand, refers to the data and instruction that are stored electronically, uh, including application, user files, and operating system.
Okay. Anyone else? Because we did a study about this, so I'm looking to see if others can answer too.
I mean, yeah. I mean, the hardware is a physical component of the computer that you can touch. Software is the components that you can't touch.
Okay. So hardware is a physical component of a computer that you can touch, you can feel, right? So like any part of the computer that is physical, you can call it hardware. For example, keyboard is a hardware. You press a key and it sends signal to computer. That's there. And then you have software. So software is basically what controls the hardware. So the program or instruction that runs hardware. So software is what controls the hardware. Um, and then when you type a document in Microsoft Word, if you have used Microsoft Word, Notepad, WordPad, MS Paint, right? Microsoft Paint, or any other softwares, those are software, right? You have used Facebook, right, on your phone. It's a software, okay? Um, so all those are part of it, okay? So then we have operating system and application software. Do you know the difference between operating system and software?
I'm sorry, the difference between a what and a what?
Operating system and software.
Operating system is manage computer hardware and software and provide common services for computer system. It acts as an intermediary between the computer and the user. It's like Windows 10, Microsoft Office, Mac OS, and Linux. But software is stored electronically and provide platform for running and like that.
Okay.
It's application software. Application software are designed for a specific task that instructed by the computer system or user.
Yeah, operating system make easier for a user to interact with the hardware, and the user can perform different tasks uh, enter the information and save it and share it and take the printouts. And the applications, there are different kind of applications available for different purpose, like Facebook, or like WhatsApp, or like other applications.
We can say, for example, which the operating system which works invisibly in the background, and the application software is what most user integrate with, like it runs on the top of the operating system.
Yeah, it runs on the top of operating system. And you do certain tasks with it, right? For example, Google Chrome. Google Chrome, why do you use Google Chrome? You use Google Chrome to um, explore internet, right? You go to google.com and you go all those things, do all those things like yahoo.com, facebook.com, things like that. You do all those things in there. So Chrome is an application, and you're giving Chrome set of instruction. Microsoft Word is for documents. You write text. Right now you can see this is what I'm writing. So this Microsoft Word is an application. And then where is it running? It is running at the top of operating system, right? And operating system is something that manages the hardware and software. Okay. So then we have networking. Why do we use networking? Anyone knows why do we use networking?
We use networking for communication, data exchange, and share resources and data.
We could also say that the internet is a global network.
Okay.
Yeah, networking is the combination of two or more computers we use to share the information and communicate with each other.
Okay. So networking is basically where we share information, right? We share information. So what are we doing right now when we are in Zoom class? We are networking. We are sharing information, right? Right
Yes.
now, right now I am sharing my knowledge with you, you're sharing your knowledge with me, and this is called networking. So networking is when you share knowledge, you share information, right? So whenever you send email to someone, you're sharing information. You're talking, you're giving them information, right? That's what you're doing. So that is basically where you do networking. Okay? So then you have database, right? Database is basically where you store and organize information. If you remember, I was giving you some example the other day about database. That with database, what we do is we store information. For example, bank. When if you have a bank account, you go to the Wells Fargo, Bank of America application, you type your username, password, and then it shows all the information about your bank, like how much money you have, how much money you took, and how much money you're spending. It is all showing to you, but it is very organized. You see that it's categorized. Okay, this is your checking account, this is your saving account. It's very organized, and that is where you basically do what? Yeah, that they basically use the database. And um, Amazon, when you go to Amazon.com and you try to buy something, you search in there and it basically brings all those things for you, very organized. Um, it's all what? It's all in a database. That information is stored in a database. Okay? So then we have storage. Storage is where the data is saved. For example, the hardware, hard drive, flash drive, USB drive. Those are what? Those are where you save the information temporary or permanently. Okay? You can delete it. For example, you create a file in a hard drive. It is your information stored in a storage. Okay? We did a study about virtualization. Virtualization is where you use one physical resource and do what? Create multiple virtual machines or virtual servers and basically use it that way. For example, um, you have a laptop, right? You have a big server. What you can do is you can install Windows 10, Windows 11, and then in one machine, you can install like 10 more Windows 11s, right? So that is virtualization where you save a lot of money. If you remember, we did a study about virtualization in our previous class, so I should not be repeating again. Okay?
Yes.
So you run multiple operating system in one physical machine. That is what you do with what? Virtualization. Okay? All right.
Yes, sir.
Any question?